Welcome to the Actuarial Data Scientists. Today, we will be learning how to calculate the mean squared error of a population, not just a sample. Let's get started. Losses occur independently with the probabilities as described below: 0, 25%, 2, 60%, 6, 15%. Using a sample size of 2, the variance of individual losses is estimated using the sample variance given by the sum of x sub I minus x bar squared. Calculate the mean squared error of this estimator. This problem, I would say, is actually really interesting. I think the core knowledge you need to have to do this problem is actually relatively straightforward, but it's asked in a kind of unique way. So I thought this was an interesting problem. So all you need to know is that the calculation for variance is the expected value of x squared minus the expected value of x squared, as well as what mean squared error is. This can show up in MAS1 in a multitude of ways. Another way of representing MSE is the variance plus the bias squared, and we do see that in some walkthroughs we've already done in the past. So you can go to other videos for that, but that's one form of asking about mean squared error. The other is quite literally, well, what is the mean of the squared errors? And so for this problem, that's what we're going to be looking at. So if you have a sample, you're going to be looking at the squared errors, and then what's the mean of that? Well, you just sum all the squared errors up, and then you divide by the sample size. Alternatively, you can think of if you have a sample with corresponding weights, so they're not all equally weighted, you would multiply them by their weights, and then you would divide by the sum of the weights. And when we're dealing with a population, that's effectively all we're doing. It's just instead of weights being something arbitrary, they are the probability of that specific error occurring. So we're going to be dealing with the overall population. That is, we know every possible state, as well as what the probability of that state occurring is. And so we can get an actual probability of seeing the given error. And then when you divide by the sum of all probabilities, that's just dividing by 1. So that's why the denominator goes away, because all we're doing is multiplying by the weight and then dividing the entire sum by 1. So the mean squared error is just the sum of squared errors multiplied by their corresponding probability of occurring. So going into the problem, first we need to know what the true variance is. So first we need to know what the mean is, so that's just the probability weighted average. So 25% of the time we see a 0, 60% of the time we see a 2, 15% of the time we see a 6. So that weighted average is 2.1. Next, for the variance of x, we can use that 2.1, that's why we calculated it, in this right side. So it's just going to be 2.1 squared. But we still need to calculate the expected value of x squared. And for that, it's the exact same thing we did for mu, but instead of multiplying by x, that is 0, 2, and 6, we want the probability weighted average of x squared. So that's going to be 0, 4, and then 36. Plugging that in, we get the expected value of x squared, then we subtract off 2.1 squared, and we get 3.39. So alternatively, this is doing it by hand in the way that I have a fondness for doing. I like calculating things on my own, but definitely in an exam setting, that's not the most efficient way always. In this case, it might be because it's only 3 observations, so it's pretty straightforward. But in the exam, you're going to have a calculator, and I think it's worth taking a moment to walk through exactly how you can plug data into your calculator to calculate variance on the fly. So what I have here is the Pearson sample questions for MAS1, and it's just a walkthrough that you're able to do. I'll include the link in the description of the video if you're interested. So just clicking through this quickly, and I might speed up what's happening here if I ever stop talking, is I'm just trying to get to the point in the exam where they give you the calculator so we can walk through this. Alright, so I have the calculator that's built into the exam on the right side of my screen and what we're walking through on the left. So again, you can do this with your personal calculator by hand or the calculator built in. And we're just going to walk through how to do this. So first you're going to go to data, and eventually we're going to be able to select a column of data and then select another column as a column of probabilities or weights. We can also have two variable x, y, and get calculations like betas and correlation. We'll cover that maybe in a future video. But here we're interested in the single variable statistics, but where we have a non-uniform weight. So, 25% weight, 60% weight, and 15% weight. And so what we're going to do is just say we have a data point of first data point is 0, the second data point is 2, the third data point is 6. Click over, 0.25, 0.6, and 0.15. So at this point we have our data. Data is in L1 and the weights are in L2. And the reason I'm walking through this again is because it's not really helpful for a 3 observation data set, but you could definitely see CAS, especially now that they're giving you Excel spreadsheet capabilities, giving you larger data sets that you have to work with. So just want to show how to go about doing that. So data is all set, and so now what we want is to calculate statistics. So that's green above the data button. So second data, we are interested in one variable statistics, where our data is L1 and our frequency, you'll see, defaults to 1, which just means every observation gets equal weight. But what we want to do is say L2 is the weight that we want to use. And let's go ahead and calculate that. And so now what we see is our data, and we can scroll on down and get a sigma of 1.841. I wish I had this prepared. So check that in your calculator. That squared should be 3.39. Do we not get that for free? We do not. Okay. So let's go ahead and second quit, second stats, stat var. Normally I just write it down because it's faster. So that to the power of 2 gets us our 3.39. So again, just showing you there are multiple ways of calculating variance, and if you have more than 3 observations, it might be faster to do it using your calculator. So just want to walk through how we go about doing that. So jumping back to the walkthrough, we at this point have calculated our true variance of this data. So next what we want to do is say, okay, well, that's the variance of x, but in this problem what we care about is MSE of this estimator. Sample size of 2 and calculate this estimate of variance, mean squared error. What's that look like? And so what we have here is an exhaustive table. So you can have a sample of 0, 0, 2, 2, 6, 6, or 0, 2, 2, 0, 0, 6, 6, 0, or 2, 6, 6, 2, because the order could be different. We have each of their corresponding probabilities. So they're independently and identically distributed. So that means that the probability of seeing 0 and then another 0 is the probability of 0 multiplied by the probability of 0. And that's how we get these probabilities, is just by multiplying them together. Next, if we know what the sample is, so in this case we're assuming it's 0, 0, well, what's x sub I minus x bar? Well, the sample mean is 0. Each of them are 0. 0 minus 0 is 0. Square that is 0. Sum that, 0 plus 0 is 0, and then you have your answer. So for this sample, it is just 0, and then we can finally calculate the thing we care about, which is the mean squared error. So again, we know the true variance, and we calculated this estimate of variance. So scrolling up again, for an estimate of variance, you divide by the sample size minus 1. So since our sample size is 2, we just divide by 1, and that's why it's just this summation. So here we're doing 0 minus 3.39, and then squaring that to get our mean squared error. of our variance estimate, and that is this number. Another functionality is the Excel table workbook flow that you have, so maybe I'll open that up really quickly. So if we go to Scratchpad, you see that we basically have Excel. It's not as nice. A lot of the shortcuts aren't, great, but you can still have cell references. So I can say u equal u plus 1, and then I can still drag fill. So in terms of these kind of more boring calculations, definitely keep in mind that you have access to Scratchpad for MAS1 now. So I'd recommend in this case, this is a past exam where that wasn't an option. You had to do all this by hand, which is a nightmare. But now with the Scratchpad, this problem is far more reasonable because you can drag and fill some of these calculations. But assuming you were doing it by hand, which is what I did initially when I prepped this, first you can simplify. So in terms of calculating this squared, this variance estimate, whether it's a 2-0 or a 0-2, you get the same answer. So we can just sum the probabilities. So 2662 is 0.09 plus 0.09 is just 18%. So that's all I'm doing here to have fewer rows in my table. And then finally, I wish that worked. So finally what you can do is also recognize these first 3 rows, although they are different samples, they all have the same value. And so once again we can say, well, what probability does 11.49 occur? Well, it's the same as just summing up these 3 probabilities. And so that's all we have here is 44.5%. So now that we have that, we can calculate our mean squared error. And again, that's just going to be our probabilities, this first column, multiplied by their corresponding values. So I have that written out here. And unfortunately, I got to zoom out to show it. So that's that 11.4 multiplied by that 45%, yada yada, and then eventually we get an answer of 25.5. Scrolling back up, we see that falls in the range of D. So D is our final answer. Do you use tabs or spaces when you code? Comment below. There is only one right answer. Until next time, have a good one.